All right. Let's see. F of x equals 3 sine of 2x. So I'm going to work my way through these 6 steps for the problems so that you get used to it. But obviously there are times when all the steps aren't going to be used. So step 1 was to find the amplitude. So what is the amplitude of this problem? 3. Step 2 was to find the period. So again, this is what we did yesterday. So period is equal to what?
2 pi over 2.
Which reduces to pi. Step 3 is to determine the scaling of it. So the scale is going to be pi over 4, so it's the period divided by 4.
It's always divided by 4.
Huh?
Is it always divided by 4?
Yes, the period is always divided by 4. Step 4, does it shift left or right? So basically, is there a parentheses there with something inside of it? No. So no shift left or right. Now, when you actually do the problems, you don't have to write that out, but I want you to see it for right now that we're checking all this stuff. Step 5, is it shifted up or down? Nope, no shift up or down. And lastly, I'm checking, is it reflected? So is there a negative in front of A? No, so it's not reflected. So the only thing that's happening is, compared to normal, is that the period is different because my period of the parent function is 2 pi. This one is half of that. And the amplitude's normally 1. This one's 3. So, let's see if I can put some grid lines up on my thing. And I'm only going to graph, like, one period of it. I'm not going to graph, like, out to, like, in the parent function, we did negative 2 pi to 2 pi. We're just going to graph, like, the one side. So, now when we get to the ones that are shifted, we have to be a little more careful with that because they can shift left and right, but so don't need to go that far. Why are we going that far? Okay. So I know I have an amplitude of 3, so I'm going to mark off 3 in the positive and the negative direction. The period is pi. I'm going to do every, like, increments of, like, 2, so I'm going to have one here, here, and here. So this is pi. There's increments of pi over 4, so pi over 4. Pi over 2 and 3 pi over 4. And you don't necessarily have to write them all out, but at least write like one so we know what increment you're counting in. Because I know it kind of like clogs up the graph to have everything on there. So now this is a sine function. Does sine start at 0 or 1? 0. So we start here at 0, and then at the next increment, I'm at 3, back at 0, down at negative 3, and back to pi, or back to 0. Now, when you connect these, it does not look like this. Okay? It's not points like this. Okay? It's curved. Okay? It's going to look like this. So, and you put little arrows because it keeps going. Okay, so obviously it still looks kind of pointed, but I can tell, I want to be able to tell that you tried to like round it off a little bit. It doesn't have to be perfect, but as good as you can. So now you've graphed your first trig function. Sure, it was thrilling. Let's see. Any questions on anything we did on that one? The pretty basic one. Okay. G of x is equal to -2 cosine of 1/2 x. So, again, step 1, amplitude is what? Nope. Amplitude has to be what? Positive. It's +2. It's the absolute value of the number that's there. The negative is going to tell us something else. Step 2, what is the period? 2 pi over 1/2, which is what? Keep, change, flip.
He says 4 pi.
4 pi. The scaling then, we take that number, we divide by 4. So 4 pi over 4, which is pi. Now, I'm not going to write out the missing steps. Is this shifted left or right?
No.
No. Is it shifted up or down?
No.
Is it reflected?
Yes.
Yes. Okay, this negative in front tells us that it is reflected. So we're skipping step 4 and 5 because we don't need them. Step 6, it is reflected.
I have a question.
Yes.
So how come when you looked at the A, how come you dropped the negative sign?
Because I said it has to always be positive. Amplitude is the absolute value of A.
Okay.
Alright, so we have an amplitude of 2. So just do this. Whoa, that's really long. It doesn't need to be that big. Alright, so amplitude's 2. So I'm going to -2 and 2. Period is 4 pi. So again, I'm just doing increments of 2 on my graph so that it's more spread out. But so this is 4 pi, 2 pi, 3 pi. Now, I'm going to graph basically the initial function, then I'm going to reflect it so you see what it looks like reflected. Okay, so I'm going to do the initial one in red, and then I'll do the final in blue. So where does cosine start normally? 0 or 1? 1. So I'm going to start, in this case, at 2 because my amplitude's 2. And then it goes down to 0. At 2 pi, we're at -2. At 3 pi, we're back at 0. And at 4 pi, I am at 2. Okay, so the cosine function graphed, when you do one period of it, it kind of looks like a V. But this function was reflected, so that means every point has to be flipped over the x-axis. Okay? So that means that instead of starting up here at +1, okay, or +2 for this particular problem, I would actually be starting at the negative value. So it's going to start down here. And I'm going to go up instead. So up to, that point happens to be the same. So at pi, it's still 0. 2 pi, I'm up at 2. 3 pi, I'm still at 0. And at 4 pi, I am at -2. So the blue is the final graph. So on like a test or a quiz, if you're graphing and you want to use a second color to show like the final shifted graph or whatever you can, sometimes what the book does is they'll do that red graph like dotted and then their final is like solid. So however you want to do it. Or if you get to the point where you feel like you can go straight to the final graph and not show all the other ones, that's also fine. I wouldn't recommend doing it like that necessarily, but you can. And a lot of times with a reflected graph, like if it was just like this, I probably would have only graphed the final. I probably wouldn't have started with the red and gone to the blue, but for the sake of you seeing it, I wanted you to see what the difference was in the two graphs. Let's see. All right, let's do this one. We'll do one more example from here, and then I'll go to our book. H of x is equal to 3 cosine of x plus pi plus 1. All right, so what is my amplitude? Amplitude is 3. Period is what? Two pi, because it'd be 2 pi over 1, which is just 2 pi. The x scale. Huh? Yeah. So it would be 2 pi over 4, which is pi over 2. So increments of pi over 2. Step 4, is this shifted left or right, and if so, by how much? Remember, that's the value inside the parentheses, and it goes opposite the direction of the sign. Inside doesn't go down.
Oh.
Left pi. And then step 4 does it, or step 5. Is it shifted up or down? And if so, by how much? That's a number outside the parentheses. Up 1. Okay, so if I didn't ask you to graph it, okay? Oh, well, I guess I should ask, is it reflected? No, okay, not reflected. So if I asked you on a test or a quiz to just tell me what's happening to the graph, this would be sufficient right here. Okay? If I ask you to graph it, then we'll do what we're about to do, the following. Okay, now, I'm going to show this graphed 3 times because we have 2 shifts happening. So I'm going to show what it looks like without the shift. Then I'm going to do the shift left or right, or well, in this case left, and then I'm going to do the shift up. But you could do it all in one swoop if you wanted to. Now, I know this is going to have to go left pi, so I'm going to go ahead and do some chunk of the graph on the left-hand side because I know it's going to be shifted left, meaning I'm going to need something on the left-hand side. So, move this down. Now, I also know it's shifted up 1, so I know I'm going to need to be higher up than 3. My amplitude is at 3. Which also means at negative 3 I'm here. Now, the period is 2 pi, so I'm going to do Just because this graph's getting shifted, I'm just going to do ones. No, I'm not. I'm going to do twos. Great, and I'm going to do a couple points on this side as well, just to go ahead and get ready. So, pi over 2, pi, 3 pi over 2, 2 pi. So over here, I'm at minus pi over 2, minus pi. So, this was a cosine function, which starts where? 1. So I'm going to do the parent function in green. So I'm going to just squiggle green up here so you know that this is just like the parent function of this particular one. So we start up here at 3, come down to 0, down to negative 3, back to 0, up to 3. So like that. Now, left pi, that means every point is getting shifted pi units, okay? So in this case, it's going over like 2 whole spots. So I'm going to do this one in, what color did I do the final in up here? Blue. Okay, we'll do this one in red. So this shift is going to be done in red. So left pi, so I take this point, it comes over to negative pi from 0. This point goes from pi over 2 to negative pi over 2. This point goes from pi to 0. This point goes from 3 pi over 2 to pi over 2. And this point here goes from 2 pi over to pi. So that's the graph shifted left pi. All right, and then the final thing, up 1. So every point is just going up 1 spot on the graph. So this is up here, 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 and here. So all of them just shifted up 1. And so that's the final graph. Now, once you have that initial function that I had in green, I could have gone straight to blue, okay, because I could have gone, well, I'm going to go from this point, I know it's going left pi up 1, and I could have just plotted that point and avoided that, like, in-between graph that I did. But right now I'm doing it so you see everything. Where are we at time-wise? We can probably do one more. Okay. So I'm going to get your actual book now. Do a couple out of here. All right, now some of these problems are matching problems, but I'm just going to skip those ones for right now because you obviously don't have your book out in front of you. But 9 through 20 are graphing the function. So let's do y equals the sine of 3x minus 4. So amplitude is what? 1. Step 2. The period is what? 2 pi over 3. The scale, we take the period and divide by 4. So that's 2 pi over 3 divided by 4, which is the same as multiplying by 1/4. So that's 2 pi over 12, or pi over 6. Is this one shifted left or right?
No.
Is it shifted up or down?
Yeah.
Yes. Okay. If there's not a parentheses, but there's still something being added or subtracted, that indicates that it's going up or down. So this one is going where? Down 4. And is this graph reflected? Oh, I guess this was actually step 5 technically, but no, it's not reflected. So I'm making this graph excessively large for no reason. Okay, anyways. All right, so initial graph. Oh, wait, I guess I need to put all this stuff on here. 1, -1. But I know this graph is shifting down. That's why, I didn't need to make it this large, but I did anyways. Increments of pi over 6. So this is, come back. Pi over 6. 2 pi over 6 is pi over 3. Wait. Yeah. Pi over 2. And 2 pi over 3. Okay, so this is a sine graph. It starts where? 0. So I start here, goes up, comes down to 0, down to -1, and back up. All right, now every point is getting shifted down 4. So my final again is going to be in blue. So down 1, 2, 3, 4. 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 And down 1, 2, 3, 4. So then my final graph is down here. All right, I want you to try this one on your own, and then we'll go over it, and we'll be done for today. We'll do like 1 or 2 more tomorrow, and then I'll give you all your problems. 14, y equals the cosine of x minus pi over 2. All right, what's my amplitude of this graph?
1.
What about the period?
4.
The period should be 2 pi. It's 2 pi over b. B was 1. So the x scale would have then been what? Pi over 2. And was it shifted at all? Or reflected? Yes. My graph is wrong. Okay, well, I need to shift my graph, but yes, it should have been to the right.
Can we get a cookie plate?
Yes.
If we, how many is it? What we do?
5.
5, we should bring cookies, and it's just like, it should be like,
Wait, how'd you get?
This should have been right.
Someone still got the right thing. I did it wrong.
Wait, yeah, that, my graph looks like that.
Well, your graph should look like that. That's the way every graph should start. But I'm going to be looking at your scaling of your graph to see if you did it correctly. Okay, that's what it should look like.
So what's the point?
Huh?
So what's the point after 2 pi? What, like,
It would just be continuing, so it would be 5 pi over 2.
Right.
because B is 1.
Alright, any questions on that one? So we'll do like a couple that are reflected tomorrow or that have more things happening in them, so that you can see. Typically, just like more of an FYI, when I have a reflection, I will typically graph the reflection with the initial function because I'll just go ahead and flip the points over where they should be. And then I'll do the shifts so that I don't have like 4 or 5 graphs on my graph. I only have like 2 or 3 on there. So, but we'll do that tomorrow and then you'll have time to do problems after that. So.